what is the Great Attractor, and why is it pulling us? When astronomers look at the sky, they do not see the Milky Way standing still against a calm cosmic backdrop. They see a subtle but measurable drift. Our galaxy, along with its neighbors, is moving through space in a shared direction at hundreds of kilometers per second, relative to the faint afterglow left over from the Big Bang. This motion is not something we feel, because everything around us is carried along together, but it appears clearly when we compare the light from distant galaxies to the cosmic background that fills all of space. This movement shows up as a slight shift in the color of that ancient radiation, as if our entire galactic neighborhood is gliding across a still surface. The effect is small, but it is precise, and it tells us something important. The Milky Way is not just orbiting locally within its own group of galaxies. It is being carried along in a much larger flow, one that extends far beyond anything we can see with the naked eye. If you're enjoying these quiet explorations of the universe, you're welcome to like and subscribe. And if you feel like it, let me know where you're listening from. Somewhere on Earth, all of us are sharing this same motion through space. Once this shared drift is recognized, it becomes impossible to ignore its direction. The motion is not random. It points toward a particular region of the sky, as if something immense lies ahead of us, shaping the paths of galaxies long before we ever noticed it. To understand how we know that this motion exists at all, we have to slow down and look at how astronomers measure movement on the largest scales imaginable, where there are no signposts, no fixed markers, and no sense of absolute rest. In space, nothing comes with a label that says still. Motion is always measured relative to something else, and the challenge is choosing a reference that is calm enough to reveal the drift of entire galaxies. Light becomes the key. When a galaxy moves away from us, the light it emits stretches slightly as it travels through expanding space, shifting toward the red end of the spectrum. When a galaxy moves toward us, that light is compressed, shifting toward blue. This change is gentle, often invisible to the eye, but instruments can detect it with remarkable precision. By measuring these shifts across thousands of galaxies, astronomers build a map of how space itself is moving and how objects move within it. At first glance, most galaxies appear to be moving away from us because the universe is expanding. This expansion creates a general redshift that increases with distance, a smooth pattern discovered nearly a century ago. But once that overall expansion is carefully accounted for, something subtler remains. Some galaxies are moving slightly faster or slower than expansion alone would predict. These leftover motions are called peculiar velocities, not peculiar because they are strange, but because they are motions layered on top of the general expansion of space. These peculiar velocities are where hidden structure reveals itself. They are the fingerprints of gravity at work on vast scales. When astronomers subtract the expected expansion from the observed motion of galaxies, what remains is a flow, a collective drift, as if entire regions of the universe are sliding toward something massive enough to tug on them across tens of millions of light years. To make this measurement meaningful, astronomers need a frame of reference that is as close to universal rest as possible. That reference comes from the cosmic microwave background, the faint, uniform glow left over from the early universe. This radiation fills all of space and looks nearly the same in every direction. Nearly, but not perfectly. When measured with exquisite sensitivity, one side of the sky appears slightly warmer and the opposite side slightly cooler. This temperature difference is not because the early universe was uneven, but because we are moving through this background. As we drift in one direction, the radiation ahead of us is compressed slightly, appearing warmer, while the radiation behind us is stretched, appearing cooler. This pattern, called a dipole, acts like a cosmic wind indicator. It tells us not only that we are moving, but how fast and in which direction. What makes this so powerful is that the cosmic microwave background does not belong to any galaxy, cluster, or region. It belongs to space itself. Using it as a reference is like measuring the motion of a boat not relative to nearby waves, but relative to the entire ocean. Against this backdrop, the motion of our galaxy becomes unmistakable. When astronomers align this motion with measurements of galaxy distances and velocities, a coherent picture emerges. Our galaxy is moving at hundreds of kilometers per second relative to the cosmic background. But more importantly, so are many other galaxies around us. They are not scattering in random directions. They are participating in a shared flow, like leaves carried along by a slow, deep current. Measuring distances is just as crucial as measuring velocity. To know whether a galaxy is moving faster or slower than expansion predicts, astronomers must know how far away it truly is. This requires a ladder of techniques, each calibrated against the next. Some rely on stars whose brightness varies in a predictable way. Others use entire galaxies, whose properties correlate with their intrinsic luminosity. Each step is careful, methodical, and grounded in observation. When distance and velocity are combined, patterns appear. Galaxies on one side of the sky show a slight blue shift beyond what expansion alone would cause. On the opposite side, galaxies appear slightly more redshifted than expected. This asymmetry points to motion through space, not just expansion of space. As more data accumulated over decades, this motion refused to average out. Instead, it sharpened. The flow extended across clusters and superclusters, encompassing our local group and far beyond it. The direction remained stable, as if marked by an invisible arrow drawn across the cosmos. This is where measurement becomes insight. If galaxies were moving independently, these peculiar velocities would cancel each other out. Random motion averages to stillness on large scales, but coherent motion does not. When many galaxies move together, it implies a shared cause. Something is influencing them all at once. Gravity is the only force capable of doing this across such immense distances. It acts on all mass, travels effectively instantly across cosmic scales through the curvature of space-time, and accumulates its influence quietly. Light can be blocked, radiation can be absorbed, but gravity leaves no shield, only motion. By carefully measuring how fast galaxies move, how far away they are, and how those motions line up across the sky, astronomers transform tiny shifts in light into a map of invisible structure. They do not see the source directly at first. They see its consequences. The universe reveals itself not by announcing what exists, but by how everything responds. This method is patient. It does not rely on dramatic images or singular discoveries. It relies on consistency. The same direction appears again and again. The same flow shows up in independent surveys. Different instruments, different techniques, different generations of astronomers arrive at the same conclusion. Something large lies in that direction, exerting a gravitational pull strong enough to shape the motion of galaxies across an enormous region of space. Once motion is measured this carefully, it stops being an abstract idea. It becomes a fact that must be explained. Galaxies are not simply where they are on their way somewhere. And the next question becomes unavoidable. If gravity is responsible, then where exactly is the mass that is doing the pulling, and why has it remained so difficult to see? As these measurements accumulated, something quietly remarkable became clear. The Milky Way was not alone in its motion. Galaxy after galaxy, spread across tens of millions of light years, showed the same subtle deviation from the smooth expansion of the universe. They were all drifting in nearly the same direction, with similar peculiar velocities layered on top of cosmic expansion. This was not a coincidence. It was a pattern. When astronomers mapped these motions in 3 dimensions, the effect became impossible to dismiss. Entire clusters of galaxies were flowing together, like schools of fish responding to a current too deep to see from the surface. Our local group was part of this movement, but it extended far beyond it, reaching across what seemed like independent regions of space and tying them into a single, coherent motion. At first, this was unsettling. Cosmology is built on the idea that, on very large scales, the universe looks roughly the same in every direction. Random motions are expected to blur out. Local gravitational interactions should cancel when averaged over enough distance. But here was a flow that did not fade. It strengthened as more data came in, its direction sharpening rather than dissolving. This shared drift revealed itself not just in galaxy velocities, but in the way clusters themselves were arranged. Rich clusters, sparse groups, and filamentary structures all appeared subtly elongated along the same axis of motion. It was as if the architecture of matter itself had been gently stretched toward a common destination over billions of years. What made this realization especially powerful was its scale. This was not a motion confined to a few neighboring galaxies exchanging gravitational tugs. It involved thousands of galaxies, bound together not by proximity, but by a distant influence. The region affected by this flow spanned a volume of space so large that light takes tens of millions of years to cross it. Any cause capable of coordinating motion across such distances had to be immense. As astronomers compared notes across continents and decades, the same conclusion kept resurfacing. Independent surveys, using different distance indicators and different telescopes, all pointed toward the same region of the sky. The flow had direction, it had coherence, and it had persistence. This was the moment when the question shifted. It was no longer simply why our galaxy was moving. It was why an entire neighborhood of the universe was sliding together, as if drawn by something ahead of them. The universe, which often reveals itself through randomness and noise, was here offering a clear signal. Once that signal was acknowledged, gravity emerged naturally as the explanation. No other force acts universally on matter at these scales. No other influence accumulates quietly over billions of years, shaping motion without needing contact or light. If galaxies were flowing together, then somewhere ahead of them lay a concentration of mass large enough to bend their trajectories collectively. This realization carried an important implication. Even without seeing the source, its existence was already encoded in motion. The galaxies were not guessing. They were responding. And their response was telling astronomers that the distribution of matter in the universe was far from uniform. It was clumped, structured, and powerful enough to guide the paths of entire cosmic regions. With that understanding, the problem sharpened again. If gravity was responsible, then the next step was inevitable: to follow the motion back to its cause, to ask where this mass was concentrated, how large it had to be, and why it had remained hidden for so long, exerting its influence without revealing its form. Once the shared motion of galaxies was established, the range of possible explanations narrowed quickly. On the largest scales, the universe is surprisingly quiet. Forces that dominate our everyday experience fade away. Electromagnetism cancels out as positive and negative charges balance. Nuclear forces are locked inside atoms. What remains, stretching across millions of light years without weakening in relevance, is gravity. Gravity has a unique character. It does not push, it only pulls. And it does so without preference, acting on all mass and energy equally. This makes it the only force capable of coordinating the motion of entire galaxies over cosmic distances. If thousands of galaxies are drifting together, gravity is not just a likely explanation. It is the only one that fits. But gravity does not act like a rope pulling objects through empty space. It reshapes the geometry of space itself. Massive structures curving space-time, and galaxies follow those curves the way water follows the slope of land. From within the flow, the motion feels natural, unforced, inevitable. There's no sense of being dragged, only a gradual leaning in one direction. This is why the observed motion matters so much. It tells us not just that something is pulling, but that space-time itself is shaped unevenly in this region of the universe. The galaxies are not accelerating randomly. They are responding to a large-scale landscape of mass, sliding along paths carved by gravity over billions of years. To produce a flow this coherent, the source must be enormous. Small clusters can influence their immediate surroundings, but their reach fades quickly with distance. Here, the influence stretches across a region so large that it includes many clusters at once. The mass responsible cannot be a single galaxy, or even a typical cluster. It must be something far larger, a dominant feature in the cosmic terrain. This insight shifts the investigation from motion to mass. If gravity is guiding galaxies, then measuring the motion allows astronomers to weigh what they cannot see directly. The faster the flow, the deeper the gravitational well must be. The direction of motion points downhill in space-time, toward a region where mass is concentrated most strongly. Importantly, this does not require the mass to be compact or luminous. Gravity does not care whether matter shines. It only cares how much there is and how it is distributed. A vast cloud of dark matter, spread across a large volume, can exert as much influence as a bright, dense cluster of galaxies. Motion responds to total mass, not appearance. As astronomers followed this logic, the picture grew clearer. The galaxies were not being pulled by something exotic or mysterious in its behavior. They were responding to gravity exactly as expected. What was mysterious was not the force, but the source. Where was this mass hiding, and why was it not obvious in visible light? This realization brought a quiet kind of confidence. The universe was not behaving strangely. It was behaving honestly. The problem was not a breakdown of physics, but a gap in observation. Gravity was doing what gravity always does, revealing structure through motion long before it reveals it through light. And so the focus tightened once more. If gravity is shaping this vast flow, then the next task is to trace that gravitational landscape, to infer the shape and location of the mass that must exist ahead of us, and to understand why it remained concealed behind the luminous patterns we see in the sky. Once gravity is accepted as the organizing force behind this vast motion, a subtle shift occurs in how the universe is understood. Light is no longer the primary guide. Instead, motion itself becomes a form of vision. Astronomers begin to read the universe the way one might read wind by watching trees bend, or currents by watching drifting leaves. The mass does not need to announce itself. Its presence is written into the paths that galaxies take. This approach has a long history in astronomy. Long before dark matter was named, astronomers noticed that stars in galaxies were moving too quickly to be held together by the visible matter alone. Clusters of galaxies behaved the same way. They moved as if there were far more mass present than telescopes could see. The lesson was clear, and it applies here as well. Absence of light does not mean absence of mass. On the largest scales, this principle becomes even more powerful. Individual galaxies are noisy. They interact, collide, and tug on each other locally. But when thousands of galaxies share a common drift, the noise averages out, and the underlying gravitational landscape comes into focus. The flow becomes a tracer, outlining invisible contours in space-time. Astronomers use this motion to reconstruct where mass must be concentrated. They work backward, asking what kind of gravitational pull would be required to produce the velocities that are observed. The answer is not subtle. The inferred mass is enormous, far greater than what can be accounted for by the visible galaxies in that direction alone. What emerges is not a single point, but a broad region where space-time slopes downward more steeply than its surroundings. Galaxies slide toward it, not because they are targeted, but because gravity always leads objects toward regions of greater mass. The motion is slow, patient, and relentless, unfolding over hundreds of millions of years. This way of seeing requires trust in physics. Gravity behaves predictably. If motion is measured accurately, the mass responsible can be inferred with confidence. The universe does not hide its structure out of malice or mystery. It hides it simply because much of its matter does not emit light. As this invisible mass is mapped, another important realization follows. The pull does not diminish sharply with distance, which means the mass is not compact. It is spread out, occupying a large volume of space. This distribution is consistent with what is known about dark matter, which forms vast halos and filaments rather than dense, shining objects. In this context, the Great Attractor begins to take shape not as an object, but as a gravitational region. A convergence point in the cosmic web where matter, both visible and dark, is more densely packed than average. Galaxies fall toward it the way rivers converge toward a basin, guided not by a single channel, but by the overall shape of the land. Importantly, this inference does not rely on speculation. It relies on repeated, independent measurements. The same mass distribution is suggested by galaxy motions, by the behavior of clusters, and by the large-scale structure seen in surveys of the universe. Different methods, sensitive to different aspects of gravity, converge on the same conclusion. The universe, it turns out, is deeply honest in this way. Even when it withholds light, it reveals mass through motion. Even when direct observation fails, cause and effect remain intact. Gravity leaves no ambiguity. It writes its signature slowly but unmistakably across the fabric of space. As astronomers refined these maps, the inferred mass grew too large to ignore. It was not a minor irregularity. It was a dominant feature of our local universe. Something massive enough to influence the motion of galaxies across a vast region lay ahead of us, shaping trajectories long before humans ever turned telescopes toward the sky. At this point, the question evolves again. If we can infer this mass so clearly from its gravitational influence, can we locate it more precisely? Can we name it, define it, and understand where it sits within the broader architecture of the universe? The next step is not about detecting gravity, but about identifying the region where its pull is strongest, and giving form to what has so far only been sensed through motion. As astronomers traced this invisible mass through motion alone, the picture gradually sharpened from a vague pull into a defined direction. The flow of galaxies did not point everywhere. It converged. When the vectors of motion were extended backward through space, they intersected in a particular region of the sky. This was the moment when the gravitational influence stopped being abstract and began to acquire location. This region lay far beyond our local group of galaxies, beyond even the nearest superclusters, in a direction partially obscured by the dense plane of the Milky Way itself. From our position inside a spiral galaxy filled with dust and stars, this part of the sky is difficult to observe. Optical telescopes struggle there. Even today, it remains one of the least visually transparent directions we can look. And yet, despite this obstruction, the gravitational signal was unmistakable. Galaxies on all sides leaned toward that same hidden area. The flow did not spiral or scatter. It aligned. This alignment suggested not just a general overdensity, but a dominant one, a region where mass accumulated more strongly than anywhere else nearby. Astronomers began to treat this region as a gravitational landmark. Not a single object, but a basin in space-time. A place where the curvature caused by mass was deep enough to guide the motion of everything around it. In this sense, the region functioned like a valley in a landscape. You do not need to see the bottom to know it is there. The slope tells you. As surveys improved, this gravitational basin grew clearer. It was not small. It extended across tens of millions of light years. Multiple clusters of galaxies appeared to be embedded within it, each contributing to the overall pull. Together, they formed a concentration of matter so large that it dominated the motion of our entire local cosmic neighborhood. This realization changed the scale of the question. The Great Attractor was not an anomaly affecting only us. It was a structural feature of the universe on supercluster scales. Its influence extended far beyond the Milky Way, shaping the trajectories of countless galaxies that would never interact directly, but were nonetheless bound by the same gravitational contour. Importantly, this region did not sit at the center of everything. It was not the center of the universe, nor a singular destination toward which all matter falls. It was simply the largest nearby mass concentration relative to our position. Gravity is always local in this way. It does not care about cosmic privilege. It cares about proximity and mass. As astronomers compared this region to known structures, a clearer identity emerged. The pull aligned with a massive assembly of galaxy clusters, part of a larger supercluster complex. What had first appeared as an invisible force began to overlap with faint, hard-to-see structures revealed by radio, infrared, and X-ray observations. The mass was not imaginary. It was merely hidden behind layers of cosmic clutter. This was the moment when the term Great Attractor entered the scientific vocabulary. Not as a declaration of mystery, but as a placeholder. a name given to a gravitational region whose influence was undeniable, even while its detailed composition remained only partially understood. The name reflects function, not form. It attracts because gravity demands that it must. By identifying this dominant region, astronomers achieved something subtle but profound. They demonstrated that large-scale motion can be used as a compass. Even when light fails, gravity still points the way. The universe can be mapped not just by what shines, but by how everything moves in response to what does not. With the region now located, the problem shifted once again. If the Great Attractor is real, massive, and nearby in cosmic terms, why is it so difficult to observe directly? Why does such an influential structure remain so elusive to our telescopes? To answer that, we have to look not outward, but inward at the structure of our own galaxy and how it shapes what we are able to see. Once this gravitational region was identified as real and dominant, it needed a name, not to mythologize it, but to make it usable. Astronomers began referring to it as the Great Attractor, a term that describes exactly what was known and nothing more. It is not a single object. It is not a point. It is a region of space where gravity pulls more strongly than anywhere else nearby, shaping the motion of galaxies on enormous scales. The name can sound dramatic, but its meaning is precise. It refers to the net gravitational influence of a vast concentration of mass. This includes many galaxy clusters, enormous amounts of dark matter, and the connective tissue of the cosmic web that binds them together. The Great Attractor is not something galaxies fall into like a hole. It is something they fall toward gradually, as space-time curves more steeply in that direction. Defining it required careful restraint. Early on, there was a temptation to imagine a single colossal object, something exotic or singular hiding behind the Milky Way. But the data did not support that picture. The gravitational pull was too broad, too distributed. The motion of galaxies suggested a landscape, not a spike. A region where mass was layered and extended, not concentrated into a single luminous core. In this sense, the Great Attractor is better understood as a gravitational basin. If you imagine space-time as a gently undulating surface, this region is a deep, wide depression. Galaxies move along its slopes not because they are aimed at a target, but because gravity always guides motion toward greater mass. The destination is not a point. It is a region where many paths converge. This definition matters because it places the Great Attractor firmly within known physics. There is no new force involved, no anomaly in gravity's behavior. The phenomenon arises naturally from how matter clumps as the universe evolves. Small irregularities in the early universe grew over billions of years, drawing matter inward, forming clusters, superclusters, and the vast structures we see today. The Great Attractor represents one of these structures seen from the inside. We are not observing it from afar with a clear outline against the sky. We are embedded in its influence, measuring it through motion rather than image. This makes it feel elusive, but not uncertain. Its definition comes from consistent gravitational effects, not from speculation. As observations improved, astronomers refined what the Great Attractor is not. It is not a black hole. It is not a singular collapse. It is not a violation of cosmic expansion. The universe is still expanding, and on the largest scales that expansion dominates. The Great Attractor simply represents a local deviation, a place where gravity slightly outweighs expansion over a limited region. This balance between expansion and attraction is subtle. Galaxies are not rushing inward, they are drifting. Over immense timescales, gravity gently alters their trajectories, bending the outward flow of expansion into curved paths that lean toward mass concentrations. The Great Attractor is one of the most influential of these concentrations in our cosmic neighborhood. By giving it a name, astronomers acknowledged its role without overstating its mystery. The name serves as a marker on the map of the universe, a way to refer to a gravitational feature inferred through careful measurement and consistent theory. It is a reminder that much of the universe is known not by sight, but by response. And yet, even with a name and a definition, a crucial question remained unanswered. If the Great Attractor is so massive and so influential, why is it so difficult to observe directly? Why does such a dominant feature of our local universe remain partially hidden, forcing us to infer its presence rather than simply see it? To understand that, we have to confront a limitation not of the universe, but of our own position within it. The difficulty in observing the Great Attractor does not come from its distance alone. It comes from where it lies in the sky relative to us, from Earth, and from anywhere inside the Milky Way. Our view of the universe is filtered through the thick, luminous disk of our own galaxy. This disk is crowded with stars, tangled with dust, and threaded with gas clouds that absorb and scatter light. In certain directions, it becomes nearly opaque. The Great Attractor sits almost directly behind this dense band. Astronomers call this region the zone of avoidance, not because nothing exists there, but because ordinary observation struggles to pass through it. Optical telescopes see mostly foreground stars. The deeper universe is washed out, hidden behind layers of galactic clutter that overwhelm faint, distant signals. This is not a small obstruction. The dust in the Milky Way can block visible light almost completely. Galaxies that would otherwise appear as clear shapes dissolve into darkness. Even large clusters can vanish from view when seen through this veil. From our position inside the galaxy, we are trying to look through the thickest part of our own home to see what lies beyond. This explains why the Great Attractor was not discovered by simply pointing a telescope and noticing something unusually bright or massive. It did not announce itself visually. It revealed itself dynamically through motion, long before it could be glimpsed directly. Gravity spoke first. Light followed much later, and only partially. To peer into this hidden region, astronomers had to change how they looked. Instead of relying on visible light, they turned to wavelengths that pass more easily through dust. Infrared light can slip between grains that block optical images. Radio waves travel almost unhindered. X-rays reveal the hot gas trapped in massive clusters, glowing not with starlight but with heat. Using these tools, faint structures began to emerge. Not a single dominating object, but a crowded region of galaxy clusters, massive assemblies bound together by gravity. Each observation filled in part of the picture, confirming what motion had already implied. The mass was real. It had simply been concealed by perspective. Even so, no single image captures the Great Attractor cleanly. It does not present itself as a neat object against a dark background. It is diffuse, extended, and layered. From within the cosmic web, structure surrounds us rather than standing apart. The difficulty is not just seeing through dust, but recognizing a basin when you are already on its slope. This limitation is deeply human. We tend to expect causes to be visible, centered, and discrete. The universe does not cooperate with that expectation. Its most influential structures are often spread out, their effects cumulative rather than dramatic. The Great Attractor influences motion not because it is sharp, but because it is broad. Understanding this reframes the problem. The question is no longer why we cannot see it clearly, but why we ever expected to. We are embedded observers trying to map a landscape while standing inside it. What we lack in clarity of image, we gain in clarity of effect. By accepting these observational limits, astronomers learned to trust indirect evidence. Motion, distribution, and gravitational influence became as real as light. The universe, once again, proved that it does not require visibility to exert power. It requires only mass and time. With this realization, the Great Attractor becomes less mysterious and more contextual. It is hidden not because it is unusual, but because of where we are. And once that is understood, a final question rises naturally. If the Great Attractor is not a single object, but a complex region of mass, then what exactly is it made of, and how does it fit into the larger structure of the universe itself? When astronomers finally began to piece together what the Great Attractor consists of, the answer was quieter and more intricate than any single dramatic object. There is no lone titan hiding behind the Milky Way. Instead, there is a dense gathering of structure, layered and extended, built from the same components that shape the rest of the universe, only gathered here in unusual abundance. At the heart of this region lie massive clusters of galaxies. These are among the largest gravitationally bound structures that exist, each containing hundreds or thousands of galaxies moving within a shared halo of mass. Between the galaxies lies hot gas, heated to extreme temperatures by gravity and glowing faintly in X-rays. This gas alone outweighs all the stars in the cluster combined. But even this is not the dominant ingredient. The majority of the mass comes from dark matter. It does not shine, absorb, or emit light. It reveals itself only through gravity. In clusters and superclusters, dark matter forms enormous halos, enveloping galaxies and binding them together into long-lived structures. It is the scaffolding on which visible matter collects. In the region associated with the Great Attractor, these halos overlap and merge. Multiple clusters sit close enough that their gravitational influence adds together, deepening the overall basin in space-time. The result is not a sharp peak, but a wide gravitational low point, shaped by many contributors acting as one. This distribution explains why the pull is so steady and far-reaching. A single compact object would create strong acceleration nearby, but fade quickly with distance. A broad concentration of mass exerts a gentler pull, but one that extends much farther. The Great Attractor influences galaxies not by dramatic force, but by persistent guidance over immense spans of time. Observations across different wavelengths reinforce this picture. Infrared surveys reveal dense fields of galaxies where optical light fails. X-ray maps show hot gas tracing deep gravitational wells. Radio observations detect motion and structure unaffected by dust. Each method sees a different aspect, but all point to the same conclusion. This region is rich in mass, layered and complex. Importantly, nothing about this composition is exotic. There is no new kind of matter unique to the Great Attractor. It is built from the same ingredients that form galaxy clusters everywhere. What makes it special is scale and placement. Relative to us, it is the most influential nearby concentration of mass, positioned such that its gravitational pull stands out clearly in our measurements. This understanding dissolves much of the early mystique. The Great Attractor is not a cosmic anomaly. It is an expected outcome of how matter organizes itself under gravity. Over billions of years, small fluctuations grow. Matter flows along filaments. Clusters form where paths intersect. Some regions become denser than others, and those regions shape motion far beyond their visible boundaries. Seen this way, the Great Attractor is a reminder that the universe is structured, not smooth. On the largest scales, matter forms a vast network, with nodes and filaments and voids. We are not floating in an even sea. We are embedded in a landscape, and the Great Attractor is one of its deepest nearby features. As this picture solidified, astronomers recognized that the Great Attractor does not stand alone. It is connected to even larger structures beyond it, part of an extended flow of matter that stretches farther than initially imagined. Understanding that connection leads naturally to the next step. To see how this gravitational region fits into the wider architecture of the universe and what it reveals about the cosmic web that binds everything together. As the nature of the Great Attractor became clearer, it stopped looking like an isolated feature and began to reveal its true context. It is not a lone basin in an otherwise smooth universe. It is part of a much larger pattern, one that stretches across hundreds of millions of light years and gives the universe its large-scale shape. This pattern is known as the cosmic web. On the grandest scales, matter in the universe is arranged neither randomly nor uniformly. It forms a vast network of filaments, sheets, and nodes with enormous voids in between. Galaxies trace these structures like frost outlining the cracks in a window. Where filaments intersect, clusters form. Where clusters gather, superclusters emerge. Gravity pulls matter along these pathways, slowly amplifying structure over cosmic time. The Great Attractor sits along one of these major intersections. It is not the end of the web, but a prominent knot within it. Matter flows toward it along filaments that extend far beyond our local region, connecting it to even larger structures deeper in the universe. The motion we observe is not just a pull toward a single region, but part of a cascading flow through the cosmic landscape. This explains why the influence of the Great Attractor feels directional but not terminal. Galaxies are not destined to stop there forever. They are moving along gravitational gradients shaped by the web itself. In some cases, matter flows through the region, continuing onward toward even more massive concentrations beyond. Gravity works hierarchically, with local pulls nested inside larger ones. One of these larger structures lies just beyond the Great Attractor, an even more massive supercluster complex that contributes to the overall flow. From our perspective, the Great Attractor dominates because it is the nearest major feature-shaping motion. But it is not acting alone. It is part of a chain of influence that extends far past what we can easily observe. Seen this way, our motion through space becomes less about being drawn toward a mysterious destination, and more about being carried along a river of structure. The universe is not static. It is dynamic, shaped by gradients of mass that guide motion over billions of years. We are participants in that motion, not exceptions to it. This perspective also resolves a subtle tension. The universe is expanding, and yet galaxies can still move toward one another, locally. Expansion sets the overall stage, but gravity writes the details. The cosmic web is the result of that interplay, expansion stretching space while gravity sculpts matter into shape. The Great Attractor is one expression of that balance. Understanding this placement transforms the Great Attractor from a curiosity into a lesson. It shows how local motion reflects global structure. By measuring how galaxies move nearby, astronomers can infer the shape of the universe far beyond what can be seen directly. The web reveals itself not just through images, but through dynamics. And once this larger context is understood, one final insight emerges naturally. The pull we experience is not something happening to us alone. It is a shared consequence of how matter organizes itself in the universe. Our motion tells a story not just about where we are going, but about where we are, embedded in a vast, interconnected structure that has been forming since the earliest moments after the Big Bang. Once the Great Attractor is understood as part of the cosmic web, its pull begins to feel less like an external force acting on us and more like evidence of where we already are. We are not being singled out. We are not drifting off course. We are moving exactly as matter moves when it is embedded in structure. Our motion is a consequence of belonging. From this perspective, the Milky Way is not traveling through an empty universe toward a mysterious destination. It is flowing through a landscape shaped long before our galaxy formed. The pull we measure today began as tiny variations in density in the early universe. Variations so small they were once measured as slight temperature differences in ancient radiation. Over billions of years, gravity amplified those differences, drawing matter together, building filaments, clusters, and basins like the one we now call the Great Attractor. This means our motion carries memory. Every kilometer per second reflects the accumulated influence of cosmic history. We are responding not to a recent event, but to a structure that has been forming since the universe was young. The pull is slow because the universe is patient. It works on timescales that dwarf human intuition. There is something quietly grounding about this realization. We often imagine ourselves as observers standing apart from the universe, watching it unfold from a distance. But the Great Attractor reminds us that observation and participation are inseparable. We are inside the system we are measuring. Our instruments detect motion because we ourselves are moving. This does not diminish our ability to understand. It deepens it. By recognizing that we are part of the flow, we gain access to information that distance alone could never provide. The universe reveals its structure through how it carries us along. Our measurements are not compromised by our motion. They are enabled by it. The pull toward the Great Attractor also reframes the idea of direction in the universe. There is no preferred center, no ultimate destination. Direction arises locally, shaped by nearby mass. In another region of the universe, galaxies flow toward different basins, guided by different structures. The cosmos is full of these quiet currents, overlapping and interwoven. What we experience is one thread in a much larger tapestry. Our galaxy's path is one of countless trajectories shaped by gravity's steady hand. Each tells a story about the distribution of matter, the history of structure, and the balance between expansion and attraction that defines the universe we inhabit. In this sense, the Great Attractor is not something ahead of us so much as something around us. Its influence is already woven into our motion, our measurements, and our understanding. We are not approaching it as outsiders. We are already within its reach, moving along a path shaped by forces that have been at work since the beginning of time. And perhaps that is the most important thing it teaches us. The universe is not a static backdrop against which events occur. It is an active, evolving structure, and we are embedded within it. The same gravity that binds stars into galaxies and galaxies into clusters is guiding us now, quietly, steadily, as part of a vast and coherent whole. There is a subtle shift that happens when this understanding settles in. The pull of the Great Attractor stops feeling like a mystery to be solved and starts feeling like a condition to be understood. Motion becomes a kind of context, something quietly present beneath everything else, like a deep current beneath the surface of the sea. From our position inside the Milky Way, nothing about this motion feels dramatic. Stars do not streak. Constellations do not distort before our eyes. Life unfolds as if the universe were still. And yet, on scales far larger than human awareness, we are moving with purpose, guided by mass distributed across a vast region of space. This contrast is not a flaw in perception. It is a feature of scale. The universe often hides its most powerful processes behind slowness. When change unfolds over hundreds of millions of years, it feels like stillness. When motion is shared by everything around us, it feels like rest. Only careful measurement reveals what intuition cannot. The Great Attractor teaches this lesson gently. It does not announce itself with light or violence. It reveals itself through alignment, through consistency, through patience. Galaxy after galaxy tells the same story, not because they communicate, but because they obey the same underlying geometry of space-time. In this way, gravity becomes a kind of storyteller. It records the distribution of mass not in words or images, but in trajectories. To read that story, astronomers learn to listen to motion, to treat velocity as evidence and direction as meaning. The universe speaks in curves rather than declarations. There is also humility here. Much of what shapes our cosmic environment does not shine. Dark matter outweighs stars. Hot gas outweighs galaxies. The most influential structures are often the least visible. The Great Attractor reminds us that understanding the universe requires letting go of the idea that seeing is believing. In cosmology, movement often tells the truth first. At the same time, this realization brings a quiet sense of belonging. We are not adrift in a random expanse. We are embedded in structure, carried along by relationships that extend far beyond our immediate surroundings. Our galaxy's path is not arbitrary. It is shaped by the same rules that shape everything else. If one were to step back far enough, far beyond individual galaxies and clusters, the motion toward the Great Attractor would appear as a gentle bend in the outward flow of the universe. A local deviation, yes, but one that fits seamlessly into the larger pattern. Expansion and attraction are not opposites here. They coexist, each defining the other. The universe expands, but not emptily. It expands while carrying structure with it. Matter flows, gathers, and redistributes even as space stretches. The Great Attractor exists because expansion gave gravity time to work, and gravity used that time to sculpt. And so our motion continues, quiet, unfelt, measurable only through careful attention. We move not toward an endpoint, but along a gradient, responding to a landscape shaped over cosmic time. The pull does not hurry us. It does not demand arrival. It simply guides steadily and without interruption, as gravity always does. In the end, the Great Attractor is less about where we are going and more about how the universe is built. It shows that structure matters, that history matters, that invisible things leave visible traces if we know how to look. And it reminds us that even in the vastness of space, nothing truly moves alone. As this understanding deepens, another quiet realization begins to take shape. The Great Attractor is not something that suddenly appeared to influence us. Its pull has been part of our story for as long as our galaxy has existed. Long before the Sun formed, before the Milky Way took on its present shape, the mass that defines this region was already gathering, already bending the paths of matter around it. Galaxies form where matter flows most efficiently. Gas follows gravity, cooling and collapsing along filaments of dark matter. Stars ignite, clusters assemble, and over time, entire galactic systems find themselves embedded in these currents. The motion we measure today is simply the continuation of that ancient process. Nothing abrupt, nothing new. Just gravity doing what it has always done, patiently and without interruption. This makes our present moment feel gently connected to deep time. The direction we are moving now was set by conditions that existed billions of years ago. The pull is not a command issued from afar. It is a legacy, written into the structure of space long before any observer was here to notice it. There is also a subtle reassurance in knowing that this motion does not threaten anything familiar. The Great Attractor is not drawing us toward a collision or a catastrophic event. The distances involved are enormous. The timescales are vast. Our galaxy will continue its slow journey, orbiting within its local group, evolving internally, forming stars and planets, long before any meaningful change in its large-scale trajectory becomes relevant. In that sense, the Great Attractor is not a destination in the way we normally think of destinations. It is not a place we will arrive at. It is a region whose influence we are already responding to, one thread in a network of gravitational relationships that extend in all directions. This perspective helps dissolve the last traces of unease that the name can sometimes evoke. There is no cosmic pull dragging us helplessly forward. There is only structure and our natural motion within it. The universe is not acting on us from the outside. We are participating from within. What makes this so quietly profound is that it transforms motion into meaning. By measuring how galaxies move, we learn not only about mass and gravity, but about the shape of the universe itself. We learn that space is not empty and indifferent. It is shaped, contoured, and responsive. It carries history in its curves. The Great Attractor, then, becomes a kind of teacher. It shows how much can be learned without direct sight. It shows how patience and precision reveal truths that spectacle never could. And it shows that the universe, even on its largest scales, is governed by simple, reliable principles that unfold with extraordinary subtlety. As we continue moving through space, carried along by these vast gravitational patterns, nothing about our daily experience changes. And yet, beneath that stillness, a deep coherence remains, a quiet order, a reminder that every star, every galaxy, and every observer is part of a larger, flowing whole, shaped not by mystery, but by gravity, time, and the gentle persistence of structure. The more this motion is considered, the more it begins to soften our sense of separation from the universe. We often imagine space as something we occupy, a vast container in which galaxies are placed. But the Great Attractor suggests something more intimate. Space is not just where things are. It is shaped by what exists within it, and we move according to those shapes whether we are aware of them or not. In everyday life, motion usually implies effort. Things move because they are pushed or pulled directly. In the cosmos, motion is quieter. It is the natural response to curvature, the way a path unfolds when space itself is uneven. Our galaxy does not strain toward the Great Attractor. It simply follows the gentle slope laid down by mass over immense time. This way of moving has no urgency. There is no moment of arrival waiting in the future. Even if our galaxy continues drifting in this direction for billions of years, the universe itself will continue expanding, reshaping distances and relationships as it goes. The Great Attractor's influence will slowly change as structures evolve, merge, and redistribute. Nothing about this is fixed forever. That realization adds an important layer of calm. Cosmic motion is not a story with a climax, it is a process without a final scene. Structures grow, influence, and eventually give way to larger patterns. The universe is always in the middle of becoming something else. In this ongoing process, the Great Attractor stands as a snapshot of how matter is arranged right now, relative to us. It is a feature of the present cosmic landscape, not an eternal anchor. In other regions of the universe, similar basins exist, shaping motion there in ways their observers might one day discover. What feels special to us is special only because of where we are, and that, too, is instructive. Knowledge in cosmology is always local in origin, even when it reaches for universality. We learn about the whole by understanding our place within it. There is a quiet elegance in how this understanding emerges. No single observation reveals the Great Attractor. No image captures its full presence. It is known through accumulation, through patience, through the steady agreement of many small measurements pointing in the same direction. It is a truth assembled rather than announced. This mirrors the way the universe itself works. Large structures arise not from sudden acts, but from countless small influences acting together over time. Gravity does not hurry, it persuades. It shapes without spectacle. And so the Great Attractor becomes less an object of fascination and more a context for understanding. It reframes motion as information. It reframes invisibility as something that can still be known. It reframes our galaxy not as a lone island, but as part of a flowing pattern written into space itself. Even now, as the Earth turns and the Sun moves within the Milky Way, and the Milky Way drifts within its larger environment, nothing feels different. The sky looks the same. The stars hold their places. Yet beneath that apparent stillness, the universe is carrying us along paths defined by mass, time, and geometry. There is something quietly reassuring in that. The universe is not chaotic at these scales. It is deeply ordered, even when its order is hidden. And our motion, guided by the Great Attractor and the larger structures beyond it, is one small expression of that order, unfolding gently without demand, as part of a cosmos that has been in motion since its very beginning. There is a moment when you sit with this long enough where the idea of being pulled through space loses any trace of tension. It becomes almost gentle, not because the forces involved are weak, but because they are so steady, so predictable, so deeply woven into the fabric of the universe that they no longer feel like events at all. The Great Attractor does not interrupt our story. It underlies it. Every atom in the Milky Way has been responding to this gravitational landscape since long before the galaxy had a name. The stars we see tonight were born already in motion, already part of this slow drift shaped by mass distributed far beyond their immediate surroundings. Even the concept of direction begins to soften here. We tend to think of movement as something that happens from one place to another. But on cosmic scales, direction is not a line. It is a gradient, a gentle bias in how space is shaped. Galaxies do not aim. They respond. If you could somehow step outside the Milky Way and watch its motion over hundreds of millions of years, you would not see a dramatic plunge or a straight path. You would see a slow bending, a graceful curve traced through expanding space, influenced by many structures at once. The Great Attractor contributes to that curve, but it does not dominate it, absolutely. It is one voice in a larger gravitational chorus. This is why the universe feels stable, even though it is never still. Stability here does not come from rest. It comes from balance. Expansion and attraction coexist, shaping trajectories that change gradually enough for structure, stars, and life to emerge. If gravity were stronger, collapse would dominate. If expansion were faster, structure would never form. The fact that we can measure a great attractor at all is evidence that this balance has held for billions of years. There is also something quietly humbling in realizing how much of this story unfolds without us. The Great Attractor does not exist because it is observed. It does not care whether it is named. Its influence would be the same if no conscious beings ever noticed the motion it causes. Understanding it is not about control or consequence. It is about alignment with reality. And yet, understanding does change something. It changes how we locate ourselves mentally within the universe. We stop imagining space as a static backdrop and start sensing it as a dynamic structure that includes us. Our galaxy is not merely located somewhere. It is moving along a path shaped by relationships extending far beyond what we can see. That realization can feel oddly comforting. It suggests that nothing is truly isolated. Even at the largest scales, everything is connected through gravity's quiet reach. Motion links distant regions. Structure links past and present. The universe holds itself together not through rigidity, but through continuous interaction. As time continues, the cosmic web will keep evolving. Clusters will merge. Filaments will thin. Expansion will slowly pull distant regions beyond one another's influence. Far in the future, the Great Attractor itself will become less relevant to us as distances grow, and gravity's reach is stretched thinner by the expansion of space. The flow we experience now is not eternal. It belongs to this era of the universe. That, too, is part of the lesson. Cosmic structures are temporary, even when they feel immense. They arise, influence, and fade, all on timescales that make permanence an illusion. What endures are the underlying rules: gravity, expansion, the relationship between mass and motion. In the end, the Great Attractor does not point us toward a destination. It points us toward understanding. It shows how much can be learned from patience, from careful measurement, from listening to what motion reveals when light falls silent. And it reminds us that the universe does not need drama to be profound. We are moving. We always have been. Quietly, steadily, carried along by structures shaped long before we arrived, in a universe that reveals itself not all at once, but gradually through attention, coherence, and time. As this idea settles even further, the motion itself begins to feel almost like a background hum of reality. Something so constant that it fades from awareness, yet so fundamental that it quietly supports everything else. The Great Attractor is part of that hum. Not a signal demanding attention, but a low note that has always been there, shaping the harmony of the universe without ever rising to the foreground. It is easy, from a human point of view, to associate motion with change and change with instability. But on cosmic scales, motion is often what allows stability to exist at all. The slow drift of galaxies through structured space is what lets matter gather without collapsing too quickly, spread without dispersing entirely. It is what allows stars to form, burn, and fade in a universe that remains balanced long enough for complexity to arise. The Great Attractor contributes to that balance locally. Its gravitational influence helps organize the region of space we inhabit, guiding matter along predictable paths rather than leaving it to scatter aimlessly. In that sense, the pull we experience is not disruptive. It is organizing. It is part of the quiet architecture that gives the universe its shape. There is also something deeply instructive about how long it took for this influence to be recognized. Humans have looked at the sky for tens of thousands of years. Yet only recently did we gain the tools to notice that our entire galaxy is moving in a coordinated way relative to the universe as a whole. This reminds us that many truths are not hidden because they are subtle, but because they require patience, precision, and the willingness to look beyond what feels immediate. The Great Attractor was never invisible in principle. It was invisible to expectation. We assumed that seeing meant light, and that absence of light meant absence of substance. Gravity taught us otherwise. It taught us that the universe leaves traces everywhere, if we learn how to read them. This has implications far beyond one region of space. The same methods used to infer the Great Attractor are used to map dark matter across the cosmos, to understand how galaxies form, to trace the growth of structure from the earliest moments after the Big Bang. Motion becomes a universal language, spoken by everything with mass. And in learning that language, we learn something about ourselves as observers. We are not standing still, watching the universe go by. We are participants in its motion, embedded in its structure, carried along by the same rules we seek to understand. Our measurements are meaningful precisely because we are not separate from what we measure. The pull toward the Great Attractor is one example of this intimacy between observer and universe. It is a reminder that understanding does not require distance. It requires alignment. Alignment with evidence, with consistency, with the quiet logic of cause and effect. As time passes, our galaxy will continue its slow journey. The sun will complete its orbits. Stars will be born and die. Civilizations may rise and fall. Through all of it, the large-scale motion will remain, changing only gradually, responding to shifts in mass distribution that unfold over spans of time almost too large to imagine. And yet, here we are, capable of noticing it, capable of tracing invisible mass through the faintest shifts in light, capable of recognizing that a hidden region of space is shaping our path, not through mystery, but through gravity acting exactly as it always has. There is a quiet satisfaction in that realization. The universe does not need to surprise us to be profound. Sometimes, it simply needs to be understood. As this understanding continues to deepen, something else begins to feel different. The universe no longer appears as a collection of distant objects scattered across emptiness. It begins to feel like a system with texture, with gentle gradients and long memory. The Great Attractor is one expression of that texture, a place where history has accumulated enough mass to quietly influence everything nearby. What makes this especially striking is how little effort gravity requires to leave such an imprint. There is no expenditure, no signal sent outward. Gravity simply exists, and over time, its presence reshapes motion. Given enough time, even the faintest imbalance becomes meaningful. Given enough patience, structure emerges. The Great Attractor is the result of patience on a cosmic scale. Billions of years of matter responding to the slightest differences, flowing almost imperceptibly toward regions where mass was already just a little denser. Over time, those small preferences compounded, turning subtle tendencies into dominant features of the universe. This is how the universe builds complexity, not through sudden acts, but through steady reinforcement. The same principle that allows galaxies to form allows regions like the Great Attractor to exist. The difference is only scale. There is something quietly reassuring in knowing that the forces guiding us are not volatile. They do not change their minds. Gravity today behaves exactly as it did when the first atoms formed. The Great Attractor does not suddenly strengthen or weaken. Its influence evolves slowly, predictably, as mass redistributes over immense spans of time. That predictability is what allows understanding to settle into calm. Once the mechanism is clear, fear dissolves. There is no unknown intention behind the pull. There is no urgency or threat. There is only mass shaping space and space guiding motion. In that light, the Great Attractor becomes less about being drawn forward and more about being situated. It tells us where we are within the local geography of the universe. It tells us that our region is not empty, not isolated, but richly structured. It tells us that we are surrounded by influence, even when we cannot see it directly. And, perhaps most quietly of all, it tells us something about how knowledge itself works. Understanding does not arrive all at once. It accumulates, like mass. Measurement after measurement. Insight after insight, until a pattern emerges that cannot be ignored. The Great Attractor was not discovered in a moment. It revealed itself gradually through coherence. That same coherence is what allows calm to emerge from understanding. When the universe makes sense, even its vastness feels approachable. Even its hidden structures feel intimate because they operate by rules we recognize. We are moving through space. That fact does not diminish stillness. It defines it. Stillness, on cosmic scales, is not the absence of motion, but motion shared so completely that it becomes part of the background of existence. The Great Attractor reminds us of that shared motion. It reminds us that beneath the quiet constancy of the night sky, everything is in gentle transition, guided by forces that do not rush, do not falter, and do not require our attention to continue shaping the universe exactly as they always have. As the idea settles even more fully, the motion we've been talking about begins to feel less like something happening in the universe and more like something the universe is doing. Not as an action, but as a state, a way of being. The Great Attractor is part of that state, woven into the long, slow behavior of matter responding to itself across time. It becomes clear that nothing about this pull is exceptional in the moral sense. There is no intention behind it, no preference. Gravity does not choose. It simply responds to what is there. Where mass gathers, space curves. Where space curves, motion follows. This simplicity is not a reduction. It is a deep kind of elegance. Seen this way, the Great Attractor is not a feature added onto the universe. It is the universe behaving exactly as expected when enough matter accumulates in one region. The fact that it feels mysterious at first says more about our assumptions than about the cosmos. We are used to causes announcing themselves. Gravity rarely does. There is also a quiet shift in scale that happens here. When we talk about galaxies being pulled, it sounds dramatic. But when we remember that this motion unfolds over hundreds of millions of years, it becomes gentle again. The Milky Way moves only slightly faster than it would if the Great Attractor were not there. The difference is subtle, detectable only through careful comparison and patient analysis. That subtlety is important. It tells us that the universe is not dominated by extremes. It is governed by accumulations. Small influences, applied consistently, matter more than sudden forces. This is how structure forms. This is how order emerges. And this has an unexpected emotional resonance. It suggests that meaning in the universe does not come from singular events, but from continuity, from patterns that persist, from relationships that endure long enough to shape outcomes. The Great Attractor is meaningful not because it is dramatic, but because it is reliable. Even now, as our galaxy continues its slow drift, the pull we've been discussing is already accounted for in the future of our region of space. Simulations of cosmic evolution include it naturally. Models of large-scale structure depend on exactly this kind of mass distribution. The universe, in our equations and in reality, moves coherently. This coherence is what allows prediction, and prediction, in turn, brings a quiet sense of trust. When the universe behaves according to understandable rules, it becomes something we can relax into, even when its scale is overwhelming. Understanding replaces anxiety with orientation. The Great Attractor, then, is not something looming ahead of us. It is something we already understand well enough to place calmly within a broader picture. It is one basin among many, one influence among countless others, all contributing to the slow choreography of cosmic motion. And as we continue to exist within that choreography, nothing about our immediate experience changes. The Earth still turns. Nights still arrive. Stars still appear fixed against the sky. Yet beneath that familiar stillness, the universe is expressing itself through motion that is steady, lawful, and deeply consistent. There is a quiet beauty in knowing that even what we cannot see is not arbitrary. It is shaped. It has consequence. It leaves traces. And by learning to read those traces, we align ourselves not just with knowledge, but with the rhythm of the universe itself. Over time, this way of seeing settles into something almost intuitive. The universe no longer feels like a place where things happen to us, but a place where we happen as part of an ongoing pattern. The Great Attractor becomes less a concept to hold in mind, and more a quiet background presence, like gravity itself, always there, rarely noticed, yet shaping everything. There is a subtle comfort in realizing that nothing about this motion is fragile. The structures guiding it are massive, ancient, and slow to change. They do not depend on fine balance or perfect conditions. They persist because gravity is patient, and because the universe gives it time to work. Even as galaxies evolve internally, forming new stars and shedding old ones, the large-scale flow continues almost unchanged. This persistence creates a sense of continuity that stretches far beyond individual lifetimes, beyond civilizations, beyond even galaxies themselves. The motion toward the Great Attractor links our present moment to a deep past, when the universe was young and nearly uniform, and to a far future, when expansion will gradually loosen these connections. We exist somewhere in the middle of that story, and in that middle, the universe is richly structured. Not chaotic, not random, but shaped by relationships that extend across unimaginable distances. The Great Attractor is one of those relationships made visible through motion. It shows how influence does not require proximity, and how connection does not require contact. There is also a quiet lesson here about perspective. From where we are, the Great Attractor feels like a destination ahead of us. From somewhere else, it would simply be one feature among many, perhaps not even the most influential. Meaning in the universe is often a matter of position. What shapes our motion shapes our questions. As observers, we have learned to ask those questions carefully, to separate expansion from motion, to distinguish local effects from global ones, to trust that consistent patterns point to real structure, even when that structure refuses to shine. The Great Attractor exists for us because we learned how to notice it, and noticing changes things. It deepens our sense of belonging to the universe without diminishing our smallness. We are tiny in scale, yes, but not disconnected. The same laws that govern the motion of galaxy clusters also govern the fall of an apple, the orbit of the moon, the structure of atoms. Gravity does not switch scales, it unifies them. This unity is perhaps the quietest insight of all. The pull guiding our galaxy is governed by the same principle that keeps our feet on the ground. There is no separate cosmic rulebook. The universe is coherent across all scales, from the familiar to the vast. As that coherence becomes clearer, the Great Attractor fades back into what it truly is. Not a looming force, not a cosmic mystery, but a natural outcome of matter responding to itself over time. A feature of the universe behaving as expected, once we learn how to listen to what motion is telling us. And so we continue, moving without sensation, carried without effort, embedded in a structure that is neither hostile nor intentional, but simply real. The universe unfolds, gravity shapes, and our understanding, slowly and patiently, follows along the same gentle curve. As this sense of coherence settles in, the idea of being carried by the universe begins to feel almost familiar. Motion stops being something to notice and becomes something to trust. The Great Attractor no longer stands out as a separate concept. It blends into a broader understanding that the universe is continuously shaping itself, and that we are always already inside that shaping. What is remarkable is how little effort this requires from the cosmos. There is no mechanism driving things forward moment by moment. No maintenance, no correction. Once mass is present, gravity does the rest. The universe sets its initial conditions, and then patiently allows them to unfold. The Great Attractor exists because enough time has passed for matter to respond fully to where it was placed. This gives the universe a certain quiet dignity. Nothing is rushed. Nothing is forced. Even the largest motions are the result of countless small influences accumulating slowly. When we detect them, we are not witnessing an event. We are reading a long record of consistency. There is also a subtle shift in how uncertainty feels here. We may not know every detail of the Great Attractor's structure. We may refine its mass, its extent, its connections as observations improve. But the foundation of understanding is secure. The motion is real. The gravity is real. The structure is real. What remains open is not whether it exists, but how finally we can resolve it. That distinction matters. It turns mystery into invitation rather than tension. The unknown becomes something to explore, not something to fear. Each new observation adds texture to a picture that is already stable in its outline. In that way, the Great Attractor mirrors the broader process of science itself. Understanding grows by degrees. Confidence emerges not from certainty, but from convergence. When many independent lines of evidence point in the same direction, trust forms naturally. And so, even without seeing the Great Attractor clearly in light, we know where it is in motion. We know how it fits into the web of structure around us. We know why it pulls, and why that pull feels gentle rather than overwhelming. The universe has made itself legible through patience. As our instruments improve, we will continue to refine this picture. Deeper surveys will trace filaments more clearly. Better measurements will sharpen velocity maps. The hidden regions behind our galaxy will become less opaque. The Great Attractor will slowly lose what little mystery remains, not by revelation, but by accumulation. Yet, even as details sharpen, the essential experience will not change. We will still live our lives beneath a sky that appears still. We will still feel rooted to the earth, unaware of the vast motions unfolding beneath that calm. And that is not a limitation. It is simply the nature of scale. The universe does not require our awareness to function. But when awareness arrives, it brings a quiet enrichment. Knowing that we are moving through a structured cosmos does not disturb our sense of place. It deepens it. We are not passengers headed toward an unknown destination. We are participants in a pattern that has been unfolding for billions of years. The Great Attractor is one expression of that pattern, one region where gravity's patient work is especially visible through motion. And in recognizing that, something gentle happens. The universe feels less distant, less abstract, more like a continuous environment, shaped by simple rules, unfolding slowly enough that understanding itself can keep pace. As this understanding continues to unfold, there is a subtle change in how silence itself feels. The silence of space no longer seems empty. It feels full of slow processes, of influences unfolding beneath awareness. The Great Attractor belongs to that silence. It does not announce itself. It simply exists, shaping motion so gradually that it can only be known through patience. This patience is something the universe seems to reward. When astronomers waited long enough, gathered enough data, and resisted the urge to simplify too quickly, a coherent picture emerged. Not a dramatic revelation, but a steady clarification. The universe, it seems, prefers to be understood this way. There is also a quiet lesson here about scale and humility. We tend to frame questions around what affects us directly, what feels immediate or consequential. But the Great Attractor reminds us that some of the most influential structures in our lives operate far outside our sensory reach. Their importance is not measured by how strongly we feel them, but by how consistently they shape the long-term story. Our galaxy's motion today is not dramatically different from what it was millions of years ago, and it will not be dramatically different millions of years from now. That continuity is what allows complexity to persist. If the universe were volatile at these scales, stable structures like galaxies, solar systems, and living worlds would be rare or impossible. Instead, we find ourselves in a universe that is remarkably well-behaved. Expanding, yes. Structured, yes, but also gentle in its large-scale motions. The Great Attractor exemplifies this gentleness. Its pull is firm enough to organize, but soft enough to allow freedom within that organization. This balance is not designed. It is emergent. It arises naturally from the laws of physics applied over immense time. And that makes it all the more profound. There is no external hand tuning the universe moment by moment. There is only consistency, played out patiently across billions of years. As our understanding matures, the emotional response changes as well. What once felt ominous or mysterious becomes grounding. Knowing that our motion through space has a clear cause, governed by familiar physics, replaces uncertainty with orientation. We know why we are moving. We know how that motion fits into a larger pattern, and we know that nothing about it is urgent or threatening. In this way, the Great Attractor becomes a quiet anchor for perspective. It pulls not just on galaxies, but on understanding itself, drawing our thinking away from isolation and toward connection. It reminds us that even at the largest scales, the universe is relational. Everything influences everything else, not suddenly, but steadily. And perhaps that is the deepest calm this idea offers. The universe is not a collection of disconnected events. It is a continuous process. Motion flows from structure. Structure flows from history. And history flows from simple rules applied patiently. We are inside that flow now, just as we always have been. The Great Attractor is not something new acting upon us. It is something we have always been responding to, whether we knew it or not. And in learning to see that, we align ourselves a little more closely with the quiet, enduring logic of the cosmos. And as that alignment becomes more natural, the universe begins to feel less like something vast we must reach toward, and more like something we are already inside, moving with. The Great Attractor no longer sits ahead of us as a concept. It settles into the background as a condition of reality, one of many quiet influences that give the cosmos its shape. There is a particular calm that comes from recognizing that nothing about this motion depends on chance. The paths galaxies follow are not guesses. They are responses. Every curve in their trajectory reflects the distribution of mass around them, written into space itself. In that sense, motion is not uncertainty. It is information. The Great Attractor becomes one chapter in a much larger story about how information is stored in the universe. Not in records or signals, but in structure. Where matter gathers, where space curves, where trajectories bend just enough to reveal what cannot be seen. This way of understanding changes how absence feels. The fact that we cannot see the Great Attractor clearly no longer registers as a gap. It feels more like a reminder that the universe communicates in more than one way. Light is only one language. Gravity is another. Motion is another still. And motion, perhaps, is the most honest of them all. It cannot pretend. It cannot decorate itself. It simply follows the shape of reality. When galaxies move together, they are telling the truth about the universe they inhabit. That truth does not demand urgency. Nothing about the Great Attractor asks us to react. It does not accelerate our lives or alter our nights. Its influence is so evenly shared, so deeply embedded, that it allows everything familiar to remain exactly as it is. The stars will still appear fixed. Seasons will still change. Time will still feel linear and personal. And beneath all of that, the universe will continue its slow, collective motion, guided by structures that do not rush and do not fade quickly. There is something quietly reassuring in knowing that even the largest forces acting on us are gentle, that the universe prefers gradients to jolts, that it shapes motion through patience rather than force. The Great Attractor exemplifies that preference. In the far future, this region of space will change. Structures will merge. Expansion will stretch connections thinner. The gravitational landscape we are responding to now will evolve, just as it always has. But the principles guiding that evolution will remain the same. And that continuity is what allows understanding to feel stable. We do not need the universe to stop changing in order to feel oriented within it. We only need its changes to follow rules we can trust. The Great Attractor, in the end, is one of those rules made visible. It shows that mass shapes motion. That motion reveals structure, and that structure connects everything, even when it lies hidden behind our own galaxy's light. We are moving, yes, but we are not being carried away. We are being carried within a universe that is coherent, patient, and quietly expressive. A universe that does not rush to reveal itself, but allows understanding to arrive at the same pace as the motion it describes. And with that sense of being carried within, rather than pulled toward, the universe begins to feel almost companionable. Not attentive, not aware, but steady, reliable. The kind of steadiness that allows everything else to unfold without urgency. The Great Attractor, at this point, has done its quiet work. It has shifted our perspective from objects to relationships, from destinations to gradients. It has shown that what matters most in the universe is not where things are, but how they influence one another over time. This way of seeing lingers. It changes how space itself is imagined. No longer an empty volume dotted with islands of matter, but a shaped environment, where every region carries the imprint of what surrounds it, where motion is never isolated, and stillness is simply shared movement. Even the idea of hidden things softens here. The Great Attractor is hidden only in the narrow sense of light. In every other sense, it is fully present. It announces itself through motion, through alignment, through the quiet agreement of countless galaxies responding in the same way. It is concealed only if we expect the universe to speak in a single voice. But the universe is multilingual. Sometimes it speaks in photons, sometimes in trajectories, sometimes in the long memory of structure itself. Learning to listen to all of these at once is what allows understanding to deepen without strain. There is no need to resolve everything. The universe does not require complete clarity to be coherent. It only requires consistency. And consistency is something gravity provides generously. Across scales, across eras, across regions of space, it behaves the same way, shaping motion patiently and without exception. The Great Attractor fits seamlessly into that consistency. It is not a special case, it is a natural outcome. A reminder that when enough mass gathers, space responds and motion follows. Nothing more is needed. Nothing less would suffice. As our galaxy continues its slow drift, nothing about our immediate experience will signal that this is happening, and that, too, feels appropriate. The deepest structures in the universe rarely announce themselves loudly. They reveal themselves only when we learn how to look without expecting spectacle. In that quiet looking, the universe becomes less overwhelming. Its vastness remains, but it is no longer impersonal. It is structured, knowable, governed by rules that do not change when we stop paying attention. We are moving through space, yes, but more accurately, we are moving with space, responding to the shape it takes around us. The Great Attractor is one contour in that shape, one gentle slope in a landscape far larger than any single feature. And as that landscape continues to unfold, patiently and without interruption, understanding does not need to rush to keep up. It can move at the same pace. Slow, steady, guided by the same gravity that carries galaxies and thoughts along paths shaped quietly over time. And in staying with that pace, something else becomes apparent. The universe does not separate understanding from experience. They unfold together. As our galaxy moves, our knowledge moves with it, shaped by the same patience that shapes the cosmos itself. The Great Attractor does not need to be resolved into a final image to be meaningful. Its meaning is already present in the way it alters motion, in the way it reveals structure without ever demanding attention. It reminds us that influence does not require visibility, and that presence does not require announcement. There is a quiet symmetry here. Just as gravity shapes galaxies without being seen, understanding shapes perception without being felt as effort. Once the pattern is clear, it no longer needs to be held tightly. It simply becomes part of how the universe is sensed. From this vantage, even the word pulling begins to feel less literal. Nothing is being dragged. Nothing is being compelled. Motion emerges because space is shaped, and shaped space offers paths of least resistance. The universe moves not because it must, but because it can. That distinction matters. It transforms the story from one of force to one of geometry, from cause acting on effect to structure guiding flow. The Great Attractor is not an agent. It is a feature of a landscape, and landscapes do not command. They invite motion by the way they are shaped. This way of thinking gently dissolves any remaining tension in the idea of being influenced. Influence here is not intrusion. It is context. It is the background condition that makes motion coherent rather than chaotic. And so the night sky remains calm. The stars do not betray their movement. The constellations hold their shapes. There is no sign, from our human vantage point, that we are part of a vast, coordinated drift. Yet that drift is there, steady and reliable, as much a part of reality as the ground beneath our feet. The universe does not ask us to notice this. It continues regardless. But when we do notice, something subtle aligns. The sense of being located in a fixed place gives way to a sense of being situated in a flowing structure, not lost within it, but held by it. The Great Attractor, in this light, is less about attraction and more about belonging. It shows that even on the largest scales, matter does not exist in isolation. It responds, it aligns, it participates in patterns that extend far beyond any single point of view. And that participation does not diminish individuality. Galaxies still have their own histories. Stars still follow their own life cycles. Worlds still turn. Local stories continue uninterrupted, even as they are carried along by larger ones. This layering of scales is one of the universe's quietest strengths. Nothing is erased by being part of something larger. Instead, everything gains context. Motion at one scale nests inside motion at another, each governed by the same simple rules, each unfolding at its own pace. As this perspective settles, there is nothing left to resolve. The Great Attractor does not demand a conclusion. It simply takes its place among the many structures that shape the universe we inhabit. Known not through spectacle, but through coherence. We move with it. We always have. And in recognizing that, the universe feels neither distant nor overwhelming, but steady, intelligible, and quietly complete in the way it allows understanding to arise naturally without hurry. carried along by the same gentle gravity that guides the galaxies themselves. And, as the sense of motion settles fully into the background, there is a final quiet shift that happens without announcement. The universe stops feeling like something to be figured out and starts feeling like something to be trusted. Not trusted in the sense of certainty or completion, but trusted in its consistency. The same gravity that shapes the Great Attractor shapes every orbit, every cluster, every slow bend in space-time. Nothing about that changes when it becomes too large to see or too slow to feel. The rules do not thin out with distance, they deepen. In that depth, the idea of scale becomes less intimidating. Vastness no longer means remoteness. Immensity no longer implies detachment. The Great Attractor is enormous, yes, but it is governed by the same quiet logic that governs the smallest familiar motions. That continuity bridges the gap between the human and the cosmic without effort. There is no need to imagine the future as an arrival point. The universe does not move toward destinations. It evolves through relationships. The Great Attractor is one relationship among many, shaping motion now, just as others will shape motion later. What matters is not where we are headed, but how the structure around us continues to change, gently, predictably, without urgency. Even the word hidden loses its weight here. Hidden implies secrecy, concealment, something withheld. But the Great Attractor is not withheld. It is expressed constantly in the way galaxies lean, in the way velocities align, in the way structure reveals itself through time. It is visible in consequence, which is often the most honest form of visibility there is. And so the universe remains quietly generous. It allows us to infer what we cannot directly see. It allows understanding to grow without demanding final answers. It allows calm to emerge not from certainty, but from coherence. We remain where we have always been, on a planet turning gently, inside a galaxy drifting steadily, embedded in a structure shaped over billions of years by gravity's patient work. Nothing about this requires attention to continue, but when attention is given, it is met with clarity rather than confusion. The Great Attractor does not loom, it does not chase, it does not arrive. It simply exists as part of the shape of things, influencing motion the way structure always does. Quietly, reliably, without drama, and in recognizing that, there is nothing left to anticipate. No threshold ahead, no final reveal waiting in the distance. Only a universe continuing exactly as it always has, carrying matter, light, and understanding along paths shaped slowly enough that awareness itself can keep pace, settling naturally into the same gentle flow. And with that, even the idea of continuation becomes gentle rather than necessary. The universe does not move in chapters. It flows. Understanding flows with it, sometimes deepening, sometimes simply resting in what is already clear. The Great Attractor remains where it has always been, not as a focal point demanding attention, but as part of the larger gravitational landscape that gives motion its shape. Its influence does not fluctuate with our awareness of it. Galaxies will continue to drift, clusters will continue to respond, and space itself will continue to stretch and curve in quiet balance. What changes is not the universe, but our relationship to it. Once the pattern is seen, it does not need to be revisited constantly. It becomes part of how reality is held in mind, the way one understands that the Earth turns without needing to feel the spin. There is a deep steadiness in that kind of knowledge. It does not excite. It does not demand. It simply supports everything else, like a foundation that does not call attention to itself because it is doing its job perfectly. The Great Attractor has done that work here. It has carried the understanding from motion to cause, to structure, to context, and finally to ease. Not because the universe has been simplified, but because it has been placed where it belongs, within a coherent whole. Nothing about the cosmos is rushing us. There is no urgency in its vast movements. Time stretches long enough for structure to form, for galaxies to evolve, for understanding to mature at its own pace. The same patience that allows gravity to shape the universe allows comprehension to settle without strain. And so the night remains quiet. The sky remains still to the eye. Beneath that stillness, everything continues exactly as it should. Mass shaping space, space guiding motion, motion revealing structure, structure giving rise to understanding. We are part of that sequence, not apart from it. Carried along, yes, but also capable of noticing the carry itself. That noticing does not change the path. It changes the feeling of being on it. The Great Attractor does not pull us toward an ending. It situates us within an ongoing reality, one that does not need conclusion to feel complete. The universe is already doing what it does best, unfolding steadily, inviting understanding to arrive not all at once, but gently, at the same unhurried pace as the motion it reveals. Then we let the motion recede into what it has always been. Not something ahead of us, not something approaching, but something already present, already accounted for, already woven into the shape of things. The Great Attractor does not need to hold our attention anymore. Its work is quiet and complete. It has shown how gravity organizes without urgency, how structure guides without force, how motion can exist without disturbance. Nothing more is required of it. Our galaxy continues its slow drift, not because it must arrive somewhere, but because space itself is shaped that way here. The stars remain steady, the sky remains calm. Life unfolds on a small, familiar scale, untouched by the vast movements beneath it. And that is perhaps the final reassurance. The universe is capable of immense structure without disruption, of deep motion without noise, of influence without intrusion. What carries us does so gently enough that stillness remains possible. There is no edge to reach, no final destination implied. Only an ongoing coherence, stretching across scales, linking the unseen to the familiar through simple, reliable rules. Mass shapes space. Space guides motion. Motion reveals structure. And structure, once understood, allows the mind to rest. So we leave the Great Attractor where it belongs. Not as a mystery ahead of us, but as part of the landscape we are already moving within. Quiet, patient, unremarkable in the best possible way. The universe continues, and we continue with it. Steadily, calmly, carried along paths shaped long before we noticed them, and gentle enough that nothing needs to change for them to be true.